Hi friends, welcome to Solidworks with Dow. Today we'll be designing the nutcracker. All dimensions are in inches. The nutcracker assembly consists of 9 parts and 2 hardwares. The material is 304 stainless steel. The 9 parts consist of the body top, body bottom, bottom ring, foam ring padding, the screw rod handle, screw rod, nut cap, screw nut, and the 2 hardwares are the number 10-24 socket countersunk head cap screw and the O-ring AS568 with an inside diameter of 0.551 and a thickness of 0.07D. The features we'll be using in designing the nutcracker are Revolved Bose, external threads, internal thread, edit material for 304 stainless steel, foam. In assembly, we'll be using advanced mate, profile center, width, and distance limit. For mechanical mate, screw. From the toolbox, we'll be getting our screw and O-ring. And lastly, we'll be doing an exploded view of the assembly. So let's get started and design the nutcracker. The body has an outside diameter of 2 inches, inside diameter of 1 7/8. The thickness of materials is 1/16 of an inch, which is 16 gauge stainless steel. The height of the body is 3 inches high. There's a 1.5 inch diameter cutout through the body in the center, vertically and horizontally. We'll be applying 1/64 of an inch fillet on the edges on both sides. Okay, so we're going to design the body of the nutcracker now. File, new, part, okay. Save drawing as body. Systems option, document properties, units, inches, 3 decimal places for dimensioning and length, okay. The scene, I want it to be plain white. Top plane, sketch. Draw 2 circles. 1, 2. Okay. Smart dimension. The outer circle diameter is 2 inches according to the drawing. The inner circle diameter is 1 7/8, which is 1.875 inch. Okay. Okay. Select the center of the circle. Hold shift. Select the origin. Make coincident relation. Okay. The drawing is fully defined. Features. Extruded Bose. We want it to go down. Sublime down. 3 inches. From the sketch plane, which is the top plane. Okay, so now we're going to select the front plane, sketch, draw a circle. Okay, smart dimension, 1.5 inch in diameter. Here to this edge. Is 1 inch. And from here to this center of the circle is 1.5 inch. 1.5. Okay, the drawing is fully defined. Features, extruded cut. From the sketch plane, which is the front plane, direction is through all both. Okay. Now I'm going to add a fillet, a small one. 1 divided by 64 of an inch. Okay, I'm going to select that edge, and then I'm going to select the first between right feature and part 3 edges. Okay, to get all 4 edges. Okay, so the outer edge is fillet, the inner edge is fillet on this side. Looking from the other side, the outer and the inner is fillet, so we got 4 edges filleted. Okay, so material, right click, edit material, steel, 304 stainless steel, apply, close, save your drawing, and the body is done. The body, top, has an outside diameter of 1 7/8, 1.875, inside diameter of 6.656. The thickness is 16 gauge stainless steel, which is 0.063, a 16th of an inch. File, new, part, okay. Save drawing as body, top, systems options, document, properties, units, inches, in inches, 3 decimal places for dimensioning in length. Okay. Scene, plain white, top plane. Sketch, draw a circle, draw another circle. Dimension, smart dimension. Outer diameter circle is 1.875, 1 7/8 in diameter. And the inner circle, inside circle is 0.656. Okay. Select the center of the circles, hold shift, select the origin, make coincident. Okay, fully define, features, extruded Bose. I'm gonna flip the direction. Oh, I want it to be blind. I want it going down. And it's a 16th of an inch, so it's 0.0625 in thickness. Okay. Material, right click, edit material. Steel, 304 stainless steel, apply. Close. Save drawing. The body top is done. The body bottom has an outside diameter of 1 7/8, 1.875. The overall height is 0.170. The thickness is 0.063, a 16th of an inch, 16 gauge stainless steel. It has an arc in the middle with a radius of 1.881. File, new, part, okay. Save your drawing. System options, document properties, units, inches, 3 decimal places for dimensioning length. Okay. Scene, I'm gonna go with the plain white scene. Front plane, sketch. I'm gonna draw a center point arc. Okay, dimension. According to the drawing, the radius is 1.881. Okay. I'm gonna select that point, hold shift, select the origin point, make coincident, okay. I'm gonna offset entities, offset a 16th of an inch, 0.0625. That this way, out, okay. Draw a line. Select the line, make relation vertical. Draw another line. Select the line, make horizontal relation, okay. Dimension, smart dimension, from that point to that point. According to the drawing, it's 0.9375. I'm gonna select that point and that point, dimension this, 0.170, okay. Offset entities, a 16th of an inch, 0.0625 it is. I'm gonna select that line and go down, okay. Now I'm gonna start trimming. Trim that, trim that, trim that line, trim that line, trim that line, okay. Line. My drawing is fully defined. Now I'm ready to revolve Bose base it. Oh, before I do that, I'm gonna add some fillets. Fillet 0.125. To the top. And 0.0625, 16th, to the bottom. Okay. I'm gonna features, revolved Bose base, 360 degrees blind, axis of revolution. It's right there. Okay, so the contour selected for us. Okay, I'm gonna select material, right click it, edit material. Steel, stainless steel, 304, apply, close. Save the drawing. Body, bottom is finished. The bottom ring has an outside diameter of 1 7/8, 1.875, inside diameter of 1 3/4, 1.750, and the overall height of the ring is 0.220. Okay, we're gonna design the bottom ring. File, new, part, okay. Save drawing as bottom ring. Systems options. Document properties. Unit, inches, 3 decimal places. Okay. Scene is plain white. Top plane. Sketch. Draw a circle. Draw another circle. Okay. Dimension, smart dimension. Diameter, outer diameter is 1.875, which is 1 7/8 of an inch. Okay. Inside circle diameter is 1 3/4, 1.750. Okay. Select the center of the circles, hold shift, select the origin, make coincident relation, okay. Drawing is fully defined, features, extruded boss, blind, I want to go down. According to the drawing, it's 0.220. Okay. Material, right click, edit material. Steel, 304. Stainless steel. Apply, close. Save drawing. And the bottom ring is done. The foam ring padding has an outside diameter of 1 3/4, inside diameter of 1 1/4, and the height is 1/4 of an inch. Okay, foam ring padding drawing. File, new, part, okay. Save drawing as foam ring padding. Options. Document properties, units, inches, 3 decimal places. Okay. Plain white, top plane, sketch, draw a circle, draw another circle. Okay, smart dimension. The outer circle diameter is 1.750, 1 3/4 of an inch. The diameter of the inside circle is 1/4 of an inch, 1.250. Okay. Select the center of the circles. Hold shift, select the origin point, make coincident relation, okay. Drawing is fully defined. Features, extruded boss. I'm going to switch the direction to down. The depth, according to the drawing, is 1/4 of an inch, so 0.250. Okay. Okay. I'm going to go and apply material. Right click, edit material. I don't want steel. I want other materials. Nope. Other non-materials. And I want polyurethane foam flexible. And I'm going to apply it. Close. And I'm going to change the color to black. At appearance, let me choose black. Okay. Save. The foam ring padding is done. The screw rod handle has a diameter of 3/8 of an inch. The length is 2 inches long and has a 32 of an inch chamfer on both sides. We're going to draw the handle now. File, new, part, okay. Save drawing as handle. Systems options, oops. systems option, document properties, units, inches, 3 decimal places for dimensioning and length. Okay. I'm gonna go to the right plane, draw a circle, smart dimension, diameter of the handle is 3/8 of an inch, so 0.375. Okay. Select the center of the circle, hold shift, origin point, make coincident, okay. The drawing is fully defined. Features, extruded boss. We're gonna go direction is mid-plane, 2 inches long. Okay. Now we're gonna add a chamfer to both ends. Chamfer, distance, angle distance 45 degrees, and it's 1 divided by 16, 32, 1/32 of an inch. Okay, we're going to select this edge, and then we're going to select that for the other edge. Okay, both edges are selected. Okay. Material, right click, edit material. Steel, stainless steel 304, apply, close, save drawing, and the handle is done. The screw rod is a diameter of 3/4 of an inch. It's 3 inches long. It has a 1/32 of an inch chamfer at the top edge. It has a 3/8 round hole cut out for the handle in the middle at the top here. It has a 70 thou gap at 550 in diameter for the O-ring. The thread is 5/8 11 UNC at about 2 inches long. At the bottom of the thread edge here, there's a 1/16 of an inch chamfer. At the bottom of the screw rod, there's a number 1024 tap, 0.380 thread tap depth, 0.505 blind hole depth. Okay, we're going to design the screw rod now. File, new, part, okay. Save drawing as screw rod. Systems, options, document properties, units, inches, 3 decimal places. Okay. Scene is plain white. Front plane. Sketch. Draw a line. Select this point. Hold shift. Make coincident. Okay. Draw lines now. And add some relations to the lines. Hold shift, select that line, this line, this line, this line. Make relations vertical. Select that line. Hold shift, select that line, that line, that line. 4 lines, make relations horizontal. Okay, it's not showing, but it's showing here. Okay. Dimension. According to the drawing, the screw rod length is 3 inches. Okay. This is 3/8 in radius, so 0.375, which will give us 3/4 in diameter when it's revolved. Okay. Diameter at the bottom is 5/8, so half of that. The radius is 0.3125. Half of 5/8. According to the drawing, this is 550, so half of that is 0.275 in radius. Okay, this dimension is 1 inch. This dimension here is 0.070. Okay, our drawing is fully defined. I'm going to go to Features, Revolved Bose, Blind, 360 degrees, Axis of Revolution is this center line here, that line there. Okay. Now I'm going to the right plane to draw the hole for the cutout for the handle. So I'm going to go right plane, draw a circle, smart dimension, 3/8 in diameter, which is the hole size. Okay, dimension from top to the middle of the hole is 1/2 inch. From that edge to the center is 0.375, 3/8 of an inch. Okay. Okay. Our drawing is fully defined. Features, extruded cut from the sketch plane through all both. Okay. Now I'm going to add some chamfers. Chamfer for the top edge and one for the bottom. So the top is going to be 1 divided by 32, 1/32 of an inch. And I'm going to select that chamfer type, angle and distance. And the angle is 45 degrees. Okay. Now I'm going to do another chamfer. 1/16 of an inch. 1 divided by 16, which is 0.0625 at 45 degrees. Same thing for the bottom edge here. Okay. Now I'm going to add a thread to this rod. So I'm going to go to, where's the hole wizard? Here it is, thread. Okay. Thread location is this edge there. I'm going to go to front plane. Okay. Blind condition going down. 0 degrees to start. Almost 2 inches in length, 1.9375. Inch die, 5/8, 11 UNC thread, so it's 0.625 in diameter, which is correct. Cut thread and right-handed thread. Okay. All right, now we're going to add a tap hole to the bottom edge of the screw rod. So we're going to put a thread hole right there. So we're going to go hole wizard, hole, I'm going to choose this one, straight tap, ANSI inch, bottoming tap hole, and according to the drawing it's number 1024. Okay. Blind, according to the drawing, the blind hole depth is 505, and the length of the thread is, the tap is 380. Okay. With thread called near side countersink. Near side countersink, I'm having it at 200 thou, 0.200 and 90 degrees. Okay. So I'm gonna select the position, and I'm gonna choose this face, and I'm gonna hover. Oh, I'm just gonna go to the origin, the center anyways. Or you can go like that. Let me see. No, in this case, I'm just gonna go right there. Okay, to center. Okay. And there we have our thread. And we can go to here, options. I think it's document properties, detailing, and shaded cosmetic thread. And it's shaded here. Okay. I'm gonna go front view section. So there we have our tapped hole, 1024. Okay, I'm gonna X that. I'm gonna go material, right click, edit material. Steel, 304 stainless steel again. Apply, close. Save the drawing, and the screw rod design is done. The screw nut has a diameter of 3/4 of an inch. The inside diameter is 0.527. The tap is 5/8-11 UNC, and the height is 0.563. Okay, we're going to design the screw nut now. File, new, part, okay. Save drawing a screw nut. Go to systems option. Document properties, units, inches, 3 decimal places for dimensioning, length. I'm gonna plain white scene, top plane, sketch, draw a circle, draw another circle. Okay, smart dimension. According to the drawing, the outer diameter of the screw nut is 0.750, which is 3/4 of an inch. The inner diameter of the inner circle is 0.527. Okay. Select the mid center point of the circle, hold shift, select the origin, make coincident relation, okay. Drawing is fully defined. We're gonna extrude it, extruded boss. Blind, according to the drawing, is 0.5625, and we want it to go down. Okay, it's going down. Okay. Now we're gonna tap that inner hole and make some thread. Okay, we're gonna go hole wizard, thread. Thread location, this top edge here. Okay, we're gonna look at it from the front view. Okay. So we want 0 degrees, blind, 0.65625 for the length of the tap, okay. Inch tap, okay. The size of the thread is 5/8 11 UNC, that's correct. Inner diameter is 527. Cut thread, 0 degrees, right-handed thread. Okay, one more thing I want to add is this part right here. I want to offset where it starts cutting. So I want it to offset 0.09375, but not down. I want it offset up. So I'm going to flip the offset, and I'm going to go OK. And I'm going to look at it from the isometric view. Okay. I'm going to put it back to the front, look at it from section view. Okay. Add material, right click, edit material. Steel, 304 stainless steel. Apply, close. Save drawing. Screw nut is done. The nut cap has a diameter of 1 1/4 inch. The overall height is 0.308. The thickness is 0.063, 16 gauge. There's a 1/4 inch dimension from this point to that top edge. There's a 200,000th of an inch hole in the center. The 40-degree angle dimension is from the center line to that line there. There's a 22.75 degree angle dimension from the horizontal line to that line there. File, new, part, okay. Remember to save your drawing. In my case, it's not Cat 1. Go to Systems Option, Document Properties, Units, Inches, 3 decimal places for dimensioning length, okay. I'm going to change the scene to plain white, okay. Front plane, sketch, center line. Select the center line, make relations vertical. I'm going to select that point, the origin, make coincident, relation, okay. Draw a line, horizontal to the origin. Make it horizontal relation, okay. Smart dimension, 100,000, 0.00100, I mean. Okay. According to the drawing. Okay. Line. Smart dimension. 40 degrees. Okay. Draw a line. Smart dimension. 0.625, 5/8 of an inch from that point horizontally to the origin. That point to that point, vertically it's 1/4 of an inch, so it's 0.250. Okay. Select this line. And I'm going to hold shift, select that point. I'm going to select that horizontal arrow. to get the angle dimension. 22.75 degrees according to the drawing. Okay. Now I'm going to offset some entities, some lines at a 1/16 of an inch. That's the thickness of the material. I'm going to select that line, offset it that way, select that line. Oops. I'm going to offset entities again, select that line, okay. Now I'm going to do some trimming, trim entities, power trim. Trim, 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 trim this, trim that. Okay, finish trimming. Draw a line to close the profile. Okay, it's highlighted. Now the drawing is still undefined. I'm going to do a dimension here to there. Okay, it's fully defined. I'm going to add some fillets. 1/8 of an inch, 1.125. Okay, 1/16 of an inch fillet. Okay. Now I'm ready to revolve this profile. So I'm going to go features, revolve boss, base, axis of revolution is the center line. Okay, now I'm ready to apply material. Select material, right click, edit material. 304, stainless steel. Okay. Save the drawing file, and we're finished with the nut cap. Now that the 9 parts of the nutcracker has been drawn, we're going to do an assembly. File, new, assembly, okay. Remember to save your drawing, nutcracker assembly. I'm going to go to Systems option, Document Properties, Units, make sure the drawing's in inches, okay. I'm going to apply scene. I want it to be plain white. Now I'm going to bring in my parts, my components. Insert. I'm going to bring in the body first. Open. I'm going to go to visibility, view origins, click here. Now my origin of my body is centered to the origin and fixed. I'm going to turn off view graphics for now. Turn off the origin. I'm going to bring in the remaining parts. Insert. Click the body. Hold Control. Body bottom, bottom ring, foam ring padding, handle, nut cap, screw nut, screw rod. Body top, body bottom, bottom ring, foam ring padding, screw rod handle, nut cap, screw nut, screw rod. Okay, I'm going to go to mate and apply some mates. I'm going to go to vents, profile center. I'm going to choose top face of the screw nut, the bottom face of the top. Okay, lock rotation. Okay. profile center, advanced, profile center mate, that top face with this face of the body, lock rotation, okay. Profile center mate, the bottom face of the body, the bottom face of the bottom ring, lock rotation, okay. I'm going to choose profile center, mate again. I'm going to choose the bottom face of the bottom, top face of the bottom ring, lock rotation, okay. Profile center mate, bottom face of the bottom, top face of the foam padding ring, lock rotation, okay. Profile center mate, I'm going to choose this face of the nut cap, the bottom face of the screw rod, lock rotation, okay. Now I'm going to apply some standard mates. Standard, inside face here with the outside face here of the handle. Concentric, lock rotation, okay. Now I'm going to do an advanced width mate. Advanced width, I'm going to choose with selection 1, that face, with selection 2, that face and the left face. And I want it to be, the constraint to be in the centered, to be centered. So I'm going to go to front view to take a look, and it is centered. Okay. Okay. Now I'm going to bring in my hardware, the O-ring and the set screw. So I'm going to go to toolbox, go to toolbox, NC inch. I'm going to go O-rings, all O-rings, AS568, okay. Bring it in. And the specification, according to the drawing, is 0.551 inside diameter, and the thickness is 0.070. Okay. Okay. I'm going to exit. I only want one. I'm going to select it. I'm going to go edit appearance and give it a color. Black. Okay. Now I'm going to bring in my other hardware. So again, design library, toolbox, NC inch, and I'm going to go bolts and screws. I'm going to the bottom left corner here, socket head screws. I'm going to choose the socket countersunk head cap screw. Bring it in. Okay, orientation is what I want. And I want to change that 1032 to 1024. Okay. I'm going to move that over a bit. Okay, so now I'm going to select this screw rod, hold shift, select the O-ring, visibility, temporary axis, view temporary axis. Okay. Click on the screen to deselect it. Now I'm going to apply some mates, standard mate. I'm going to select that axis with the O-ring axis. Okay, coincidence. Okay. I'm going to move my screw rod up a bit so I can see my O-ring. I'm going to apply another mate from this face underneath to this face of the O-ring and tangent. Okay. I'm going to apply a mate from this face to this face of the screw, and it's concentric, lock rotation. Okay, and one more mate here. I want to apply this face to this face, and I want to lock it. Okay. So as I move this, okay, so we're gonna apply couple more mates. So I'm gonna turn off visibility of the axis. Now I'm gonna apply a mechanical mate. Mechanical, screw. I want to choose this face here and this face. That should mate it. Okay. Revolution per inch, 1, reverse, align. Okay. I want to test it out. Okay, so it's going through the body. We want to limit that distance. So we're going to apply one more mate. So mate, advanced mate, distance. Okay, so I'm going to mate selection. I'm going to choose underneath here where the O-ring is and this top face here. And I'm going to give it a minimum value of 0.070 is the thickness of the O-ring. And I'm going to do that the same here, 0.070. And the maximum value for the distance is 1.375, 1 3/8 of an inch. Okay, okay, okay. Gonna try it out. I'm gonna go to the front view. Okay, so it's stopping at the minimum value distance here, 70 thousandths of an inch. And it should stop, the travel should be 1 3/8. The maximum distance travel is 1 3/8. So I'm gonna go to section view to take a look at that. Okay. And it is. Turn off sectional view. I'm gonna go to diametric view. Turn on real view graphics. Make it look nice and shiny. Let it go down and up. Okay, there we have it, the assembly of the nutcracker parts. Lastly, I'm going to do an exploded view of the nutcracker assembly. Exploded view. I'm going to select the bottom ring padding. Zoom out. I'm going to drag it on the y-axis. Step 1 is done. I'm going to zoom in. Select the bottom ring. Zoom out. Drag it on the y-axis down. Step 2 is done. Zoom in. Choose the bottom. Zoom out. Drag it on the y-axis down. Step 3 is done. Choose the body. Drag it down on the y-axis. Step 4 is done. Zoom in. Select the screw. Drag it down. Zoom out. Step 5 is done. I'm going to select the nut cap. Drag it down on the y-axis. Step 6 is done. Select the screw nut. Drag it down on the y-axis. Step 7 is done. Select the top of the body. Drag it down on the y-axis. Step 8 is done. I'm going to zoom in. Select the O-ring. Drag it down on the y-axis. Step 9 is done. Select the handle, drag it across on the x-axis. Step 10 is done. Select the screw rod, drag it down on the y-axis a bit. Step 11 is done. Okay. I'm gonna go to diametric view. I'm gonna go up here, right click, collapse. Go back up here, select Nutcracker assembly, right click, animate explode. Okay. Go back here, select Nutcracker assembly, right click it, animate collapse. Okay. There we have it, the exploded view of the Nutcracker assembly. I hope you like this project. If so, please like, share, and subscribe to my channel. Thank you very much for watching.